Welcome back, and in this video we are going to work on simplifying radical expressions. So what does that exactly mean? So when we use this term, the biggest rule that we have is that the radicand, so radicand, just spelling that out, cannot contain any exponents larger than the index. Okay, and so just as a reminder, the radicand is the quantity underneath the radical symbol, the check mark. Okay, so what we need to do is look at each factor and see if there are any, or if it is larger than the index, if it has an exponent that is larger than the index, then we need to represent that exponent in terms of the index and pull out sort of these sort of the factors that we can to make it smaller than the index. Okay, so this part is requires a little bit of patience, and actually we're going to probably need a few properties of exponents. So in this first one, you'll notice that it looks kind of scary. Okay, we have very large exponents, 30, 25, 35. Yeah, large. Also, there's this number 243, kind of big, kind of scary. Okay, it'll be fine. To simplify this whole thing underneath the radical, it may be in our best interest to use some properties of radicals, and these may look familiar. The first one is if we have the nth root of a times b underneath the radical, that can be expressed as the nth root of a times the nth root of b. Okay, similar to exponents. Foreshadow, foreshadow, foreshadow. And then the next one is the nth root of a divided by b. Well, per the first property, you might imagine that this is going to be nth root of a over nth root of b. Okay, so that's another property that we're going to use on occasion. Perhaps here. And then the last property that you may encounter is if you have kind of two radicals. We won't see any in this video, but you could encounter it. So you have the mth root of the nth root of a, and what this says is that you can represent this as the nth root of a. Okay, you can combine it. Sort of like our exponent on exponent property, how we multiply the exponents. Ooh. So, in any case, so first thing I'm going to do is, just for my own sanity, I need to kind of tackle these one at a time. So I'm going to break these apart. I'm going to do the second property. Okay, I'm going to express it as a quotient, or I'm going to take the quotient and break it into two radicals. So fifth root of y to the 30, z to the 25. And again, I'm showing more work than you maybe need to. So if you want to show less, that is totally fine. Okay, and then the next one is to break it apart using that first property, where I have a product underneath. I'm going to do the fifth root of y to the 30, and then the next one would be times the fifth root of z to the 25. Oops. And then the fifth root of 243 in the denominator, and then times the fifth root of x to the 35. So I just split up all the factors. Okay, now this overall goal of simplification, remembering that we want the radicals to, or the radicand to have exponents no larger than the index, requires me to do a little bit of creative thinking. So I know that the index is 5. Right? That's the fifth root. So perhaps I can try to express the exponent as a multiple of 5. Specifically, okay, if I look at the first one, if I think about 30, I know 30 is 6 times 5. Okay, so what I can do is say that this is y to the 6th all raised to the 5th power. Okay, and you might say, oh, well, why did you do that order? And that's because, well, remember, properties of exponents, if I have an exponent and an exponent, all I need to do is multiply the exponents. And so I'm going to kind of do that similar procedure for the next one. So z to the 5th and then to the 5th for 25, so 5 times 5 is 25. And then the denominator, okay, I'm not sure about 243 right at the minute, and so I'm going to focus on the other one. There's going to be an x, and I know 35 is 7 times 5, so I'm going to say this is going to be x to the 7th to the 5th. Okay, and then okay, I better deal with this 243 thing. It ends up, you may need to use a factor tree. I'm going to say try dividing by 3, and what you end up with is 81. And what this ends up being is, so 243 is the same as 3 to the 5th power. So this is really 3 to the 5th power. Okay, now I wrote my work like this because remember that when we're dealing with even or odd roots, all I need to worry about is the quantity underneath. I don't need to worry about absolute values. But also, this form has the added advantage that the exponent and radical are going to cancel each other out in each case. Oops. So what I'm going to end up getting here is, in the numerator, okay, the first term is going to simplify just to y to the 6th. The second component is going to simplify to z to the 5th. And then in the denominator, I'm going to have the 3 left over and x to the 7th power. Okay, and that is going to be my final answer. I don't have any more radicals, so I can't simplify further. And then I'm going to move on with my life. The other thing that I always tell students to think about is that the index is really saying you want to find 5, or in this case, 5 similar things, and for every 5 similar things, you're going to pull one out. So in this case, I had 5 groups of 6 y's multiplied together. So I ended up pulling the y out 6 times. I'm sorry. Let me rephrase. For y to the 30th, I can write that as I have 5 y's chunked together. Okay, and that's going to occur 6 times. And for each chunk of y's, so if you want to imagine, I have 5 y's multiplied together. Okay, and what the radical does is it takes that chunk of 5 things and pulls out 1 outside of the radical. Okay, so that's another way of thinking about a radical symbol if this sort of procedure isn't clicking for you exactly. Okay, now for this next one, this is going to take a little bit of time to kind of wade through, so I want you to pause the video and try it on your own. My hint here is that it's not going to be, well, first of all, I'm going to say it's not as pretty as this first one, but you might have to do a little bit more thinking about breaking the exponents up so that you can see that power of 3 popping out. Alright, and hopefully you had a little bit of time to pause the video and try this out on your own. What I did to kind of work on this one was to first recognize that 81 is 3 to the 4th power. Okay, and getting to that step may have taken you a little bit. You know that 81 is 9 times 9, and you may have stopped there, but you can actually break 9 down further into 3 times 3, so you have 4 3's multiplied together. And then m, now this one, I'm going to represent that 4 as a 3 plus 1, and you'll see why in a moment here. And n to the 8th, well, I'm going to say that is 6 plus 2. Okay, and actually this 3 to the 4th, I'm going to write that as 3 plus 1. And I'm doing this each time because I want to see a 3 or a multiple of 3 pop out. Okay, and now using properties of exponents, okay, I'm going to say that this is cube root of 3, and then I have, now using properties of exponents in reverse, I have 3 to the third times 3 to the first. Okay, breaking that up. With the m's, I'll do something similar, m to the third times m, and then n, I'm going to do n to the sixth times, and then n squared. Okay, and now I can simplify this a little bit more. I'm going to say that, well, this first term, I'm not going to write it out using this property here. If you want to, great, go for it. I'm going to say that I'm going to kind of do each one of these at one at a time. So this first one, 3 to the third, would actually come outside the radical as a 3. Okay, 3 to the first, that has an exponent that is already smaller than the index, so actually I can't do anything with that. I'm just going to leave that. It's going to have to stay underneath the radical, so I'm going to have times a cube root of 3 somewhere in this problem. And then m cubed, that's going to come outside as m. Okay, and it's an odd root, so I don't have to worry about absolute values, but if I was pulling it outside, I'd have to, and I had an even root, it would need to be absolute value. N to the sixth would come outside as n squared. Oh, and I forgot that m right there. The other m here, that would stay underneath there. And then n squared would also have to stay underneath because it has an exponent less than the index. So, a few longer problems here, and so what I want you to do is there's a quiz at the end of this video. Take a shot at that one, see what you can do with that problem.